they've taken this idea of evaluation to kind of a whole new level in terms of these micro tests up and down the stack, right? To literally the amount of compute that's going to be used for this answer, and how does is that sufficient, or how quickly this answer is going to come. Hey Sam, welcome back to San Francisco. How are you doing?
I'm good. I'm good.
So we're going to talk today about agents moving now to real deployment, right? There was this story about agents becoming a thing in 2025. I think there were some hiccups as companies tried to figure out how to actually deploy. But we just this week had this amazing, impressive announcement from Google around something called AlphaEvolve, right? Which is a stunning example of agent deployment and actually getting things done. And they've been secretive about this, but now they're releasing a bunch of details about what this agent has done over the last year. And it's done some amazing things like rewriting a 1960s algorithm that textbooks didn't think could possibly be done. It's squeezing an extra 0.7% of compute out of Google's global data centers, right? 0.7% doesn't sound like much, but at
Well,
Google
that's
scale,
huge.
it's massive. We will get into that. So we're going to talk about what AlphaEvolve has done here exactly. We're going to break it down into what sort of tooling it uses, and then the takeaways for our enterprise audience, and what you need to think about as you take this and do it yourselves back home. So, Sam, right? Amazing facts, right? Alpha Evolve is this new coding agent that in 2023 they said they first demonstrated building a single function, right? But now what it's doing, it's evolving beyond just a single function and it going into entire code base generation, right? And developing much more complex algorithms.
We should point out too that like the whole thing around TPUs, etc., is matrix multiplication. So to be able to do these kind of models, both for training and inference, this is really what a large element of what they're doing. So any sort of improvement there is huge. And it sounds like probably the improvement that they've made probably actually pays for the whole training of, perhaps one of the Gemini models. Google's working at such a, they are the hyperscaler. You've got to look at them like that. So any of these kind of improvements that they can make just save them so much money. Right. And it just enables, things to get quicker, all these sort of benefits. So you can certainly see why Google's been interested in
These massive billion people applications, whether it's maps, whether it's search, whether it's YouTube. They've invented with this AlphaEvolve agent a new data center scheduling heuristic, right? Which essentially looks at various GPUs or TPUs and which one is memory constrained and can kind of quickly reconfigure so that things are much more efficient. The takeaway number one is maybe a little intimidating in the sense that hey, they've got this production grade, essentially agent operating system, right? That it's not just based on single model calls. It's an asynchronous distributed pipeline that's made up of a controller and an assemble of LLM samplers, a program memory database, and a fleet of evaluator workers, if you want to call them, all running concurrently for throughput rather than latency. What do you think of this setup?
So okay, the idea here is not super duper new, right? It's just a unbelievably good execution in what they've done. So the idea is that, and I'll sort of explain a bit more general than just the AlphaEvolve. The idea is if we can use an LLM to come up with some answers or to come up with some ideas that we can generate answers from, as long as we've got a way to check those answers, that's like a verifiable sort of thing. In this way, I think they're calling them either the verifiers or evaluators.
Evaluators, yeah.
Uh, um, then you can come up with lots of different ideas that you can then have a system that just those ideas get automatically checked and verified of whether they work or not. And if they do work, then you can use them. Now, often with things like this, what you'll find is that maybe they work in one element, but not in another way. So then what happens is you want your agent or your system to remember that and then sort of go, well, okay, we know that kind of like this is good for helping this part of the problem. So maybe we sort of evolve it, right? And this is where the whole idea of sort of evolutionary, ideas come in. And this is not a new idea. This is again something that's been around in machine learning for 30 plus years. And then the idea is that as you're coming up with some kind of algorithm or something that you're trying to evolve, you tend to sort of chop them up and then you have a way of testing what we call sort of like a fit function of where to see like, okay, does this work or not work? And each time that you get at something a little bit better, you evolve those ones. It seems to me with Evolve, they're doing the same kind of things with these sort of programs, with these sort of multi-function programs or sort of code bases, in that you keep sort of mutating until you get something that's going to pass all the evaluators or all the verifiers in there. Is a very cool idea. Because if you think about it, we always hear stories about things like, that Edison took, 10,000 tries to create the light bulb or whatever. And back then, those were physical things that he actually did. He probably had to build like, thousands of actual light bulbs or whatever. Most of the things that we want to see, huge advances on now, we can sort of digitize those. So if we've got some way to evaluate and verify, a solution, we just need sort of interesting ways to generate, solutions. And that's what they've done here. Obviously they're using the sort of latest and greatest Gemini models. There's a whole bunch of things going on. And it's interesting that they've now converted this to an agentic sort of system as opposed to just sort of being, perhaps a little bit simpler as it was in the past. We should also point out that this system is coming not that long after they rolled out, I think it's called Co-Scientist, right? Google Co-Scientist. So at Next, that there was a little bit of talk around that. In that case, they were trying to basically create scientists that could come up with new ideas. And they got this sort of agentic system to sort of pretend that it's like a new PhD, student to do a literature review, find out all the sort of, things about something, and then propose new ideas and go and write sort of a full thesis, a PhD thesis, which people normally spend, a couple of years on. If we are going to get AGI or something like that, we're going to see the acceleration of all this scientific research and stuff so that we can benefit from it, right? The things that we really want are things like cures for cancer, cures for disease, all this sort of stuff. So Google's kind of applied this for something that they're already experts at, right? We know that from the TPUs and stuff like that, they've been really good at doing matrix multiplication. So the fact that they've built something that has improved on every single thing that their humans have come up with is a big step forward.
Yeah, yeah, that's huge. So I think for the viewers here, um, you know, read the paper, right? So there's the blog post, but then there's the paper that goes into to more detail with diagrams about how this holistic system works. It's pretty impressive. You touch on a main point, right, which is the evaluators. Here's the prompt sampler, the rich context containing information from past trials and ideas, right, which goes into this LLM and ensemble, right? And then you're looking at diffs and then after the evaluation, going into the database and then informing the prompt again in this loop. I think the point number two, in terms of the takeaways we were going to go over, Sam, we essentially covered, right, which is this objective. They make a big point about objective automated evaluators. Are basically the safety net of your system, right? So every AlphaEvolve iteration is accepted or rejected by a user-provided function that returns machine gradable metrics. So you run through this evaluator cascade, right? This tiered test funnel, all the way down to the benchmarks, right? So the takeaway there is production agents need deterministic scorekeepers, right? And run automatic. They're run automatically at every step.
The evaluators and verifiers is a huge thing that we're seeing at the moment. If we look at sort of something like DeepSeek R1, the whole thing that allowed them to sort of bootstrap a lot of what they did was that they had verifiable rewards. So this is now sort of being termed. People are starting to talk about RLVR. Reinforcement learning with verifiable rewards. The whole idea of verifiable rewards is now being picked up by the Quen teams, by a bunch of different teams. So this idea of verifiers is a big thing. The interesting thing that DeepSeek found was that if you can sort of verify on the mathematics, it also got more intelligent on things that you couldn't necessarily check and verify. Now, what Google sort of proposed here is something that really can be checked, right? We can look at these equations and we can see, okay, do they actually get the same result that is the correct result? Do they do it faster? Do they do it slower? Do they do it at the same speed, right? In the same number of steps or whatever.
Yeah.
And so that again is something, when you've got something that can be evaluated, this is huge. And for one of the takeaways I would say for people in enterprise is to start thinking about, in your industry, what are the verifiable rewards, right? If you can start thinking about that now, and you can be clear about that now, you're able not only then to sort of like look at possibly fine tuning these models for your particular task, but also creating these agents for your particular
Yeah.
task.
What is your metric in your industry that you can actually specifically measure against? Um, and they've taken this idea of evaluation to kind of a whole new level in terms of these micro tests up and down the stack, right? To literally the amount of compute that's going to be used for this answer, and how does is that sufficient, or how quickly this answer is going to come, and so on. So really good reading there. I think let's move to the third part, or the third takeaway, which they really had high up in the paper and blog posts as well, which is idea of hybrid model serving and prompt level memory, but basically pairing Gemini Flashed, right, which is the quicker, slightly smaller model, cheaper, faster breadth, with Gemini Pro, which is obviously the fuller, flagship model, a little more expensive, higher quality, depth, but sampling thousands of ideas with these two models while still landing these breakthroughs, right? So, can you talk a little bit about like how enterprise companies can treat model selection, this prompt construction, as a tunable system? For some folks, that can be hard to get their head around.
So definitely for most things, your prompts are not going to be changing a lot on the fly.
Yeah.
Now, in this case, they do actually have a sampler that's trying to come up with perhaps better prompts to be able to do the different things that they're trying to do. But for most industries, you want to get a really good prompt. So it was really interesting last week when Anthropic's prompt for Claude got leaked. Right. And it turned out this is like a 26,000 token prompt. This is like some huge prompt. Right. But there were fascinating little things in there about how they were priming it for everything from, dealing with election results right through to, how to get better at sort of thinking and stuff like that. Okay. The key takeaway I would say there is, don't be a cheapskate on your prompts. Right. When I look at, people's prompts, when people ask me, okay, can you look at my agent and tell me why it's, how can we improve it and stuff like that? And I look at the prompt, and the prompt's like, 100 tokens.
Yeah.
It's like, no, 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 no. You want something that's going to deal with outliers. You want something that's going to be able to guide, people, like guide the agents and guide the model through to exactly what it is that you
And the
want.
reason is because
Right.
now there's all this context left,
Yes.
right, that can support that.
And so, okay, at the moment, the sort of the top Claude models, the Gemini 2.5 models, they are really good at coming up with these prompts. And if you basically have a simple idea yourself, you're much better to put it into one of those things and say, hey, I need a prompt about this. Can you elaborate on this? They're often
What are the
called
things I need to think
enhancing.
about?
Yes,
Yeah,
like
this is my
what?
domain.
Yeah, and you can do it as a conversation, but nowadays actually the models are getting really good at just say, "Hey, here's what I want. Give me a really good prompt for it." And the prompt it will give you is like a page long or a couple of pages long,
Right.
right?
So not to feel bad if you've got like 100 or even 1,000 different variables that you're kind of testing.
Yeah, like the that obviously the more variables you're testing, you got to factor that in. But the thing I find is that like more and more, if you can just start with a really good prompt, that's going to be a huge thing. Now, coming when you're going to production, you'd want to save money as much as possible. So coming up with the really good prompt on a really high end model and then using it on a smaller model, usually if it's from the same family, tends to work really well. So using the top of the line Gemini models for coming up with prompts for Gemini Flash, etc., which I think is what they've done in the paper. I doing the same thing with Claude. Claude, top models can come up with really good prompts for their haiku model, etc. And then you can save money by going for the smaller one. One of the big things that we're starting to see, and I suspect we'll maybe hear some more about this next week as well, and it's not just Google, this is all the providers, is that the providers are now starting to make sort of automatic routers that will just take whatever prompt you're putting into it and decide which model is best for that.
So give us two or three things that this technology does to automatically route. So when does the system know when to use Flash and when to use the higher, more expensive model?
So the basically there are a number of different ways to do it. Depending on which way you're doing it, you can sort of do it manually, where you just decide like, okay, all the prompts that are really quite short, we're going to send those to Flash or something like that. Um, or if we detect, so you can have like what's called a classifier that says like, okay, this prompt is about, small talk, right? Hey Sam, how you doing? Hey Matt, what's up? That kind of thing,
Got it.
right?
Yeah.
And then it says, well, I don't need a big model for that. Let me just go to the smallest model. But if you say, okay, I need to know how, to calculate this and this and this and this and this, that's going to be routed to the big model. So that can be one way. It's like a actual classifier, which is a separate model that sort of sits there and decides that. The other way is people can do matrix factorization, which I'm not going to go into too much, but basically think of it as a really big grid that looks at your prompt and sees, okay, what's the closest kind of prompt that we've seen something like this before, and what did we route it to then? What was the right model for it then? Now, that sounds really simple when you're talking maybe, a thousand, different prompts, but they're talking about billions of prompts, right? So they've got the data to know, okay, which ones, and the thinking there is that if that prompt didn't work with that model, people are not going to repeat it. Right. So therefore, you're going to see, when someone's got a prompt and it's working with a model and they keep doing it again, that's going to increase the probability of that model being used. And so I think we'll see in the next 6 months, most of the model providers provide some kind of smart API where it's like, okay, if you ping this API, we will just work out which one we think is the best, and we'll charge you at a discounted rate
Right.
because of that.
Yeah.
So that's something that
But they're going to
it's
have to
insane.
open up and allow you to choose dynamically too, right?
You will
Because
still be able to do the other way, yes, and if you've got a really specific thing.
let's finish off with the takeaways. I think so, a lot of these takeaways kind of dovetail with each other. This number four in terms of takeaways is basically tangible ROI comes from having these domains with clear metrics. We've essentially covered it. I just wanted to make that a separate point because I talked about it in your framework evaluators. They're linked in some way, right? The evaluators need metrics, but to your point, your enterprise application needs to have these clear metrics. Just to touch on a few things from the Google paper in terms of what they accomplished real quick as examples, right? They reclaimed 0.7% of the data center capacity, right? By proposing a new Borg scheduling heuristic. They cut a Gemini training kernel's runtime 23% and overall training time by 1%. Shrinking flash attention latency on GPUs by up to 32%, and then simplifying TPU register transfer level while preserving correctness, right? So again, the takeaway is having this concept of better is actually a real-time number the system could compute, right? Whether it's latency, cost, accuracy. So that's point is now thoroughly made. The fifth takeaway really is just looking at the prerequisites and limits you've got to plan for, right? So you this is machine gradability stuff, right? This is not going to work in a wet lab or using manual feedback. That's out of scope from a lot of these agents, especially from AlphaEvolve, right? Where your search can consume hundreds of compute hours per candidate, right? So you've got to consider your capacity for those costs. And then there's this whole idea around memory, right? And this database that's evolving, right? That was part of that loop. Um, and as it pertains to these larger code bases that are evolving. There's been a lot of news there as well, right? Where I think as these agents are being demonstrated, especially with this week's example of AlphaEvolve, you're seeing announcements from LangChain and from Llama Index, and there's Open Memory, right? Where so all announcements this week where some of these memory components are being built out for enterprise folks. Just kind of curious if you're any takeaways that you've seen from this week's announcements.
Look, yeah, there's been a bunch of things recently in this sort of sphere. I think one of the things to sort of point out, and this sort of goes back a little bit to what you were talking about before, right? Is that uh, in many ways, sort of the way our memory works, we think of it as a very human kind of thing, and that these systems haven't been very good with a lot of that now, up until sort of recently. I think what everyone's rolling out now as a memory sort of system. We also know that, like, Sam Altman was talking about this recently at the Sequoia event, is that they see this as being one of the huge things, is that the more their system knows, about you, the more it can adapt to you, the more it can make, give you better responses. And if you think about it, it's quite a while now since Google moved from having search be the same search for everyone around the world to now hyper localized, hyper personalized search, where probably the two of us sitting here did a Google search, we will get possibly different
Oh yeah,
results, right?
absolutely.
Based and we're sitting in the same room, right?
Right.
On the same Wi-Fi. So this is, and all that comes with sort of memory, right? So as these sort of memory things are happening, what we're sort of seeing is that this enables a whole bunch of new applications, right? It makes the agents get better. Now, that's in relation to a user, but also if you think about it, just from yourself, the more times you do something, if you remember, if you're just sort of a blank slate each time you do it, you don't learn anything.
Right.
But if you've got a memory and you keep doing it and you realize, oh, well, this works and this works, and oh, this only works when this situation is there, suddenly now you're getting a lot more intelligence. So definitely memory is a part of increasing this intelligence. And so this is something I think that, LangChain, Llama Index, a whole bunch of different startups are working on this sort of thing as well, to create sort of, you know, memory that agents can use, not only to remember something about a user, but also just to improve their own sort of
Yeah.
abilities.
Remember a couple of months ago, I was proposing let's do a pod on memory, and you were downplaying it because a lot of the providers basically concluded temporarily, evidently, right, that the memory was not interesting to users. Users weren't asking for it. Has that suddenly changed?
Yes,
Politically?
this is a massive change. So I won't say the company because I told you about this, but yeah, that last year there was literally, when I was talking to one of, I was very interested in memory, talking to one of these companies that we've already mentioned today, that makes a framework for agents. And I asked them, like, and they said, well, developers don't seem to be that interested in it. So we're not prioritizing it. It wasn't that they didn't think it was an important thing, but they just didn't think it was like the thing to focus on. And yes, we're now probably what, 9 months later, it is something, or now maybe a year later, it is something that people are starting to focus on. Like you mentioned, we've seen things from LangChain, we've seen things from Llama Index, going on onto this. I think each of these things, the other thing too, looking at it from a business case, each of these things that allows them to sort of slightly differentiate themselves from the competition is becoming a big deal. The whole agentic framework thing is now a huge business, right? It wasn't, even when we first started recording back in last year, it really wasn't what it's like now. You've got Google jumping in, right? They announced the ADK recently. I know another big model provider is also working on an agentic framework that's not public yet. So yeah, there's a bunch of things like that that are forcing these specialized startups to incorporate things like memory. And I think that's really a big deal. In many ways, for the building agents, you're almost going to get the memory for free, meaning that you will still have to pay for it, I'm sure, but I mean, like, you're not going to have to worry too much about it, right? It's going to be done by one of these things. What I think people in enterprise should be really focused on more now is, what are these verifiable rewards in their industry? And how can we do this? Like, you mentioned some really interesting things there about, well, Google sort of prefaced that this can't work with with sort of human feedback or something like that. And while that's true, you could sort of you could train a model to listen to a sales call and give a feedback, give a score, and to be able to see, did they actually close the sale or not, right? And that then suddenly starts to become verifiable feedback. So we've seen already the sort of voice boom of where the voices are getting to be so good that they can just talk to people on calls. As we sort of incorporate things like the memory, like these verifiable things, you're going to see these things get better and better at sales, at customer service, at doing, various things like this. Looking at that paper, they're starting to sketch out a sort of framework of like how you should be thinking about building agents for your company and building these sorts of things.
Right. So Sam, really good takeaways. You have to have a metric that the agent can score itself against, right? One thing we didn't mention is just the tool vibrancy, right? Google referred to this in the paper, but basically, while most of the results were for Google itself as AlphaEvolve, they're going to make this available in some form. They didn't give many details, but basically the tools out there are becoming really robust. So just stay on top of that, right? And that includes the compute, right? These are compute heavy tasks. You got to stay on top of that, but things are getting easier. Costs are coming down by 4x a year. And then, is your code base annotated and traceable enough for this diff style evolution, right? For things like leveraging that memory that's increasingly built in, leveraging those evals and so on that can make your application so much better. So we could go on and on. We're going to see you next week. I'm sure it's going to be a lot from IO next week. So thanks, Sam, for joining us.
Pleasure. Well,